You type a question into a chatbot, and instantly, words start appearing on your screen. It feels like magic. But behind that blinking cursor, there isn't a thinking mind. It is a high-speed digital assembly line. To understand how this works, we need to clear up some of the labels. Artificial intelligence is the broad goal of teaching machines human tasks. Inside is machine learning, learning patterns from data. Deeper is deep learning, using neuron layers for complex information. At the center are large language models, systems built to generate human text. The names you recognize, like ChatGPT, Gemini, or Claude, are the user-friendly interfaces built on top of these models. Think of the chatbot as a storefront window. The LLM is the actual manufacturing plant doing the heavy math behind the scenes. Let's follow a request like "Explain Java" as it enters the factory. It first arrives at a station called the Tokenizer, which is powered by the system's central processor. Because computers can't read letters, this station slices words into smaller chunks called tokens. Each receives a unique ID, like a barcode. These blocks are carried to the GPU for embeddings, turning every token into a mathematical coordinate in a giant 3D grid. This grid is how the AI understands a word's flavor. By placing tokens at specific points in this space, the machine can map out the relationships between them. Words with similar meanings end up huddling together. Puppy and dog are neighbors, while bicycle is far across the map. This is the core of machine language. It doesn't use a dictionary. It understands meaning through the distance and the geometric relationships between points. Once the words are mapped, they enter the factory's central engine room, the transformer. This is where the most powerful GPUs perform their heaviest work. Within this engine is a tool called the attention mechanism. This allows the AI to grasp context rather than reading one word at a time. Take the word Java. To figure out if it means coffee or computer code, the system draws connections to the words around it. If it sees explain and code, it draws thicker lines to those tokens, signaling that they are the most relevant. Calculating these connections for every single word across a 1,000-page document creates mountains of calculations. Only the parallel processing power of a GPU can keep up. This breakthrough is why the AI can have a long conversation without losing its place. It pays attention to the right parts of the prompt to stay on track. But there is a significant bottleneck. As the conversation gets longer, the system naturally wants to reread everything from the very beginning to figure out the next word. To speed things up, the factory uses a short-term memory buffer called the KV cache. It's essentially a digital clipboard. Instead of redoing the math for every old word, the system stores the results on a clipboard to reuse them instantly. But this clipboard lives on the small GPU memory chips. If conversations get too long, it overflows, triggering an out-of-memory error. This is why AI has a context limit. Whether it's 32,000 words or 100,000 words, there is a physical limit to how much information the factory can keep on its clipboard at one time. We've finally reached the end of the line. All those maps and context clues are combined into a final prediction table. This chart shows how the system picks a starting point, like the word protein, and then looks at every possible word that could follow it. It assigns a percentage score to each one, guessing which token is most likely to come next based on its training. Once the system picks the winning token, it immediately streams it to your screen. This is why AI responses look like someone is typing in real time. Then the self-feeding loop begins. The new word flows to your screen, and at the same moment, it circles back to the very start of the factory to help the machine predict the word that comes after that. This loop happens dozens of times a second until the AI predicts a hidden stop token, which shuts down the entire assembly line. When you pull back the curtain, there is no conscious mind thinking about your question. There is just an incredibly fast loop of math, predicting one single word at a time.